What is a limit? What do we mean when we're talking about limits? Well, the notation, of course, is this. We've got a function involved. We're looking at what happens as x gets close to a particular value a. And we're asking what is happening to the y value. So as x gets close to a, what does the function value get close to? As x gets close to a, what does f of x get close to? Now, get close is a very unmathematical term, right? And we're going to have to somehow quantify this. So here we go. This is our informal definition. So I will say L is the limit of f of x as x approaches a if f of x can be made arbitrarily close to L by choosing x sufficiently close to a. What do I mean? Well, I'm still using the word close, but I'm using some adjectives here: arbitrarily close and sufficiently close. Right? Or are those adverbs? Those are adverbs. Anyway, arbitrarily close, sufficiently close. Sufficient. There's one that I think we can work with pretty quickly. Sufficiently close is like close enough, right? That is, as long as I keep x close enough to a, then maybe my f of x will be as close as I want to L. And this arbitrarily close is a sense of, there's a sense of arbitrariness. It's sort of, who's going to choose? It's kind of arbitrary as to who chooses how close you want to be. Well, the point is, if it doesn't matter who chooses, how close do you want the function to be to L? I'm saying the function is getting close to L. How close do you want? You choose how close you want it, then I can get it that close. If someone else chooses how close they want it, I can get it that close too, right? As long as I can make f arbitrarily close, no matter who chooses that closeness, if I can get f that close by just taking my x's close enough to a, then I say that L is the limit of f as x goes to a. All right. Graphically, it looks something like this. You've got your function, whatever it looks like. You got your value of a here, and you think the limit is this, let's say L, right? It looks like that as x is close to a, the function value here is close to L. And you say, how close do I want to be? You say, I want to be, within this range. That's what I'm going to call, this is what I call close to L. Right? Now, someone else may come in and say, no, I don't think that's close. I want to change this. But someone's going to pick a value that's going to tell me how close they think they are. And then I'm going to say, okay, if you tell me that, then I'm going to slide this over and that over, and slide this down and that down. And I say, okay, if you take any x values in this range down here, then my function values will be as close as you said you wanted them. When someone else comes in and says, no, I want to be this close to L, no more than plus or minus a little bit here, then I'm going to say, okay, well, as long as as long as I keep my x's within that close to a, then my function values will be as close as you wanted to L. And if I can always do that, no matter who tells me how close they want to be, if I can always find a little range down here and says, okay, pick these x values, you're close to a, then the f of x will be close to L, then that's what I mean by the limit. L is the limit as x goes to a of the function f. So, close. Eventually we'll give the strict definition, which uses these Greek letters epsilon and delta to put a specific quantity on how close do you mean here and how close do you mean down here. But for now, I think this is good enough that the function can be made to be as close as you want to L by choosing x sufficiently close to a. That's going to work as our informal definition of the limit.